Hello everyone, welcome to Module 3, Matter and Energy. One quick announcement as we get started on this. This was changed a little bit from what your syllabus said this module would be about, and that it is including some of the same material, actually all of the same material in terms of the advanced measurements. We'll see that in sections 3.1 and 3.4. However, I'm also including essentially this section, and the reason for that is so that Module 4 is not overly long. So we're essentially finishing Chapter 2 with looking at density again and going over a few more things with conversion factors, and then completing Chapter 3, and then going back to hit Chapter 1, which we skipped over earlier. I wanted to go through Chapter 2 in the first week so you would be ready for lab, and then talk about the things related to your lab for this coming week. But then this other information, I think it's best to cover it here, and then that allows us more time for Chapters 4 and 5 in the coming week. So the first section here is on density, which is a continuation of what we were seeing in Module 2. Okay, so these are the learning objectives for this section of the module. So use dimensional analysis to perform calculations in which you convert between any units, memorize the definition of density, calculate density from mass and volume measurements, use density as a conversion factor in performing calculations, and record measurements of mass and volume of objects in order to calculate their density. Make volume measurements directly or by water displacement. Okay, so these are the ideas we'll be looking at in this section of Module 3. You might remember we talked at the end of last time about derived units, and we did see this in lab. So the idea that you combine more than one measurement in order to come up with a something that's measuring more than one attribute of an object. Density is an example of a derived unit, as we'll see. In fact, we're showing density right here. We have mass divided by volume. So density, again, density is a derived unit. It's a ratio of mass to volume. And density is something we'll be looking at quite a bit during the lab this semester. In terms of the derived units we've looked at so far, it's probably the one we will use the most. So we're spending a little bit extra time on it. If we know information about a substance in terms of its mass and volume, if we have calculated those or measured those, we can calculate the density. So that's something we will be doing in lab. If we know the density, we can use it as a conversion factor to find information about either mass or volume. One property of density is that it is a close that. It is a property of a substance, so we can tabulate that property, and we're showing here a variety of substances and what their densities are. So any sample of pure gold, for example, has this density of 19.3 grams per cubic centimeter. If it is not pure gold, it will probably be less than that. And historically, there are stories of people throwing crowns in bathtubs to decide if they are pure gold or not. Likewise, any sample of pure aluminum would have a density of 2.7 grams per cubic centimeter. So we see a lot of things on this table, and we could look up any pure substance and see what its density would be. You might notice water is on here. Water has a density of 1 gram per cubic centimeter. This is the only one that we need to remember. Okay, so we need to memorize water is 1. It's easy to remember the number 1. And a lot of properties are defined such that they are 1 for water. You'll also notice that ice is a little bit less than water at 0.92. We will maybe talk later in the semester about why it is less. But for now, this is why ice floats. The density is less than water. So if you put a solid and liquid together of different densities, the the solid will float in the liquid if it's less. So we have charcoal here as well, would float in water, whereas any of these that are have a greater density than water would sink in the water. Okay, I want to look at a couple of example problems. First of all, just a couple definitions here. So this, again, this is the density of water. We can write this in terms of cubic centimeters or in terms of milliliters. So remember, cubic centimeters and milliliters essentially mean the same thing. If we were looking at a larger substance, so where kilograms would be more appropriate or cubic meters would be more appropriate, this is what that would be. So 1,000 kilograms per cubic meter. Again, density is defined as mass per volume. We can write it in this way. And I want to look at a couple of example problems. I'll go ahead and show both of them here. So what I would recommend doing is pausing your recording, see if you can solve these, and then once you have done that, come back and watch the rest and see my answer for these problems. Okay, so let's go ahead and continue. I am showing here, I'm going to go through this problem. So the first question, a chunk of metal has a mass of 150 grams. I'm going to underline that to remind us that it's important, and a volume of 24.9 cubic centimeters. Okay, so if we know the mass and we know the volume, we can find the density just by using this definition. So density is mass divided by volume. So we should take 150.0 grams divided by 24.9 cubic centimeters. Again, remember to include the units here. And then if we do the math, so you want to just do this on your calculator, you would get 6.02 grams per cubic centimeter. The question does not specify the units, so it is fine to use these same units of grams and cubic centimeters. One other thing to notice is we have three significant figures in our measure of volume. We have 4 in our measure of mass, so the density will have 3 significant figures. Okay, the next question. A piece of platinum metal has a volume of 4.49 cubic centimeters. What is the mass? So we're trying to find the mass. We know the volume. So we probably need more information here, right? We probably need to know, so we have volume, mass, we probably need to know the density. So what is the density? Well, the other piece of information you have here is that we are dealing with platinum metal. This is something that you would need to look up. So this was on, I'm not going to go back to the table, but this was on that table we had just looked at. If you need to pause and go back and look that up, you can. When you do, you will see that it is 21.5 grams per cubic centimeter specifically for platinum. So you might, in some cases, have to look up on that table in order to find the density of a substance. Okay, so now that we know that, we want to find the mass. So we're going to do this the same way we do any kind of conversion problem. We look at what we have. We have this number and we have this number. And between these two numbers, this one has 1 unit, this one has 2 units. So we'll start with the one that has only 1 unit, so 4.49 cubic centimeters. And then we want to set up a conversion factor so that the cubic centimeters cancel and we have hopefully mass as our unit on the top. And we see those are the units we have in density. So we would put 21.5 grams on top, 1 cubic centimeter on the bottom. And again, you can set this up with either the mass or the volume on top, depending on which one you need. We needed mass on top this time. Okay, so the cubic centimeters cancel. We take 4.49 times 21.5, and we get 96.5 grams. Okay, so that's the solution to those two questions. Okay, so continuing on, I wanted to talk about just a few more things before the end of this section of the module. When we are in the lab, we will be finding mass and finding volume in order to calculate density. So when we find the mass, we want to count every single digit. Here we're showing, this is you'd be reading it by just by using your eyes. The balance we have in the lab is a digital balance, so it has several significant figures there. You want to write down each one. You should have, I believe, 4 decimal places. So you write down all of those when you find the mass. For volume, we will often be finding volume by displacement. So here we're showing a graduated cylinder. We will use graduated cylinders quite a bit when we are measuring density. So you'll notice there is this kind of curvature to the water in the graduated cylinder. And to read this correctly, we want to be looking at the lowest point on here. And then in addition to that, we want to be guessing the last digit. So it's kind of showing this zoomed in. And you see these little marks here. These are imaginary marks. These marks are not actually on the graduated cylinder. But you would be looking for the point at which you see the line, the bottom of this kind of intersecting. So we have, so 1, 2, 3, 4, 5. This would be 6. So it's between 5.5 and 5.6, and this zooming in is showing that maybe it's around, so 1, 2, 3, 4, 5, about 5.5, so about halfway between those. So you're guessing that last digit. Make sure that you're always guessing that last digit, especially on these graduated cylinder measurements. That will affect your grade in the lab when you do this lab. And then you'll, typically what you would do is you would then add your substance to the graduated cylinder. This volume would go up, and then you would measure it again. And the difference between those would be the volume of the substance. We will go over this procedure a little bit more when we get to lab, but just a brief overview of what to expect there. Okay, this is not new. This is stuff we talked about in Module 2, but I just want to show it again to remind you. As we're doing problem solving with unit conversions, and density is kind of our first example of that, we want to do these things we talked about. So sort the information. Make sure, again, you're including units for this. As you are making this, you might have to refer to a table, so the density table, for example, if that were not provided in the question itself. Come up with a strategy and then solve the problem. You're letting the units basically do the work for you here, right? So you follow the units to figure out how it works, and then check if the answer makes sense. So again, we talked about this in the last module, but just a reminder, we'll see this again with density, and then at the end of the module when we look at specific heat. So make sure you're using these steps. Okay, so that is the end of this first section of Module 3. Go ahead and complete Worksheet 3.1. If you have any questions on anything on the worksheet, please put them on the discussion board. And then when you are ready, proceed on to Module 3.2.